Okay, thank you. Okay, so I will first describe what the topic is. Then I will highlight some engineering challenges, then our actions and the research directions, and give some references. So that's the survey plan. So first, what are the functionalities of these constellations? So as you know, there are lots of things which are happening beyond Starlink, which has already about 10K satellites. There are like 3 big Chinese projects along the same lines. There is the Amazon project. There is a European project. So this is meant for communications from Earth observation and for geolocalization is an old field, but the main 2 drivers are number 1 and number 2. So these constellations are for mostly the big projects are for internet access, broadband access, and they offer coverage solutions, which is universal, at least under appropriate latitude constraints when you have certain geometries for the constellations, without interruptions, provided there are sufficiently many satellites per orbit and sufficiently many orbits. Spectral efficiency is high when a proper beamforming and proper antennas are designed, both with a cell phone and the satellite. And slow latency, we'll see on that a bit later, thanks to low orbit. And it's resilient. I mean, it's easy to get rid of transatlantic cable by having some anchor floating close to the thing, right? But getting rid of this constellation is more difficult, right? So this is a topic, a picture of the how these things work. You have, say, a UE. You have first satellite, second satellite, and a so-called anchor station. Typically, the bands to be used would be in the millimeter wave. Currently, the Ka and Ku bands are dominant, but the 5G bands are also used. And you would have typically communication, say, from you to a first satellite, which would be on these bands, plus inter-satellite communication, which would use laser beams. And again, from the second satellite prime to the anchor station, you would have a second, say, millimeter wave link. And as you realize, you can have no anchor station on a continent or on a country and still serve this country just by relaying through satellite. So that's the striking thing, which can be combined with other things, as you know, like Earth observation, joint communication and sensing. And that's how these things work. And with the striking fact that you can cover broadband a country on which you have no, basically, only customers, but no equipment as anchor stations. So the engineering challenges are numerous. Spectral efficiency is one of them. And you will have a demo made by Philippe Martins in the afternoon of the greener wave antenna, which is used by OneWeb. So you need, let's say, a RIS or an antenna, which is a more classical one, close to the phone in order to communicate satellite if you want to go broadband. So there are lots of interesting things in terms of mastering interference and to assess what spectral efficiency is. There are very beautiful and important questions on terrestrial network, non-terrestrial network interference and coexistence. I already mentioned antennas and RIS-enhanced networks. I will say a few words on that. The completely new thing for guys in communication is that mobile stations move and very fast. And that's a very interesting thing. So there will be a talk by Ashutosh a bit later on the Doppler shift, on which we worked a lot. There are lots of very beautiful things on beam management, on the very frequent handovers due to the speed of satellites, which play the role of base stations. That will be the talk of Sanjoy. Very beautiful questions on multi-hop routing with this extremely fast change of the geometry of the base stations, and where the basic Dijkstra type algorithm do not work. There are fantastic questions on terrestrial, non-terrestrial network interplay 5G offloading, vertical handovers. And there is a broad thing which is pretty much in line with what we heard in earlier talks this morning, which is the edge computing, right? And that's a very important new dimension, and something like a spatial internet is clearly under potential design with a combination of observation and computing and communication and more. You all heard about the projects of having edge computing with including AI in this setting. Okay, what are we doing? We have a large project with BPI, which features a company which has launched its first satellites called Univity. And this joint work with Greener Wave, which is designing the antenna. And you will see the demo in Philippe's lab, and Onera, which is, and this is under the umbrella of Telecom Paris. We have a Uber-Curien project with South Korea, very active country in this field. As I will say, we also were asked to prepare a report for the Académie des Sciences, which led to an S7, namely G7 report, which was delivered last month. And we were quite active in trying to make this known by giving lectures and a list a set of countries where these things were given. We also try to be active in the open level. There is something planning, scientific and industrial planning called SRIA, and we contributed in 25 and 26 on that with Philippe Martins. So there are lots of challenges, and the first one is spectral efficiency. How can you at all communicate with a satellite, which is to the closest 350 kilometers broadband, right? And so, especially if this network of satellite is very dense, you will have interference, secondary lobes, and things of this nature to be taken into account. The geometry is completely new. There is a visibility cap. There are new association cells. You will hear Ashutosh discussing Doppler-based association cells. A new structure of interference with a spherical geometry. And a new way compared to what was done in cellular network to assess spectral efficiency. The main challenge and completely new concept is that of BS mobility, and no joke in terms of mobility. So Doppler shift cannot be ignored. The frequency of handovers, the stability of links is very short, a few seconds for the densities of satellites which are currently used. And this leads to completely new multi-hop routing mechanisms, new types of handovers, and you will see the demo of Ashutosh and Philippe later on today. So one thing that we did, and this was mostly the work of Ashutosh and Philippe, is design a simulation platform, and we jointly, as a group of people whom I would describe in a second, design in complement to that math tools based on stochastic geometry and dynamical system theory to analyze all these questions. The simulation platform, let's start with that, integrates all the available open source information on LEO satellites and emulates the evolution of this LEO satellite in real time. Emulates, I mean, based on the structure of the antenna system, the coverage areas and their motion and dynamics. And the ongoing implementation of, there is an ongoing implementation of routing protocols for a given pair of transmitter and receivers, right? So that's what is done, and you will see more of it later. The math thing is very active. So the interplay with terrestrial and non-terrestrial is pursued mostly with Univity because they work in the 5G millimeter wave for direct interaction between terrestrial 5 or 6G networks and non-terrestrial networks on the same bands. But most of the activities with South Korea, Namyoon Lee, former student of mine, who is now in Postec. And that's how through MAE, Ministère des Affaires étrangères grant. We started a line of thought, which I will say a few words on the Walker architecture. We'll give a picture of it a bit later, which is the current one used for this multi-altitude and single-altitude constellations. That's also with Geist, Chang-Sik, also former student who is very active in that. We work actively on RIS-enhanced non-terrestrial network. Paul is here. I think I saw him. Where is Paul? Here, up there. Has been working very actively on multi-hop extension thanks to RIS in urban environment. And there is a heavy earlier work with Junsei, who is also in South Korea. Ali is here. Yeah, we are working on densification converse. We proved that if you densify too much these networks, not only you have diminishing returns, but even you have a decrease of spectral efficiency, right? And we had proved that already in the non-spherical case, but in the planar case. But now it's proved in the and we can design constellations beyond which, if you go on densifying, you will lose, right? Due to the excess of interference when you take into account secondary lobes and things of this nature. There is the work. I underline Ashutosh because we will give a lecture, so no need to go to that. And the second thing is the presentation that Sanjoy will make on frequency of handovers, distribution of SINR at handovers. These are just the extensions of the thing which were done in the planar case using stochastic geometry to the spherical case. Well, one important thing I would like to mention is this multi-altitude walker. So there is a dimension on the mass side, which is about the dynamical system. You have the rotation of Earth, and you have the rotation of satellites on their orbits, right? Which is determined by the altitude. And we proved that these dynamical systems, in most cases, are non-periodic. Observed from a point on Earth, it depends on the Dionne-Fontaine properties of the speeds, the vector of speeds. I could explain that if you want in detail later. But it means the ephemeris of the satellites seen from a given point on Earth will not be periodic almost surely in function of the space of parameters. Okay, so lots of things are going on, not only in stochastic geometry, but on the dynamical aspect of that, right? Okay, now collaborations. We would like to collaborate with the European project. It's called IRIS Square, and we are working on that. And we want also to warn governments on the fact that there is this big competition for these low orbits. And one key point is that it is proved now that the RTT of this constellation beats, but not of an order of magnitude, but beats the end-to-end delay, the RTT of terrestrial network. Because propagation in space is faster than in fibers, and fibers, I mean, they go this valley, this thing is in the ocean, they go one route, right? Whereas if you have a dense enough satellite constellation, you can optimize the route and get RTTs, which are sometimes only about half of what the RTT would be. And so people have to think, if you combine all the aspects of observation, communication and real-time action on this. So we want to warn government that ignoring that or not knowing what happens might be damageable in a few years, right? So okay, so that's what we do, and we are very active on that. So we have been pushing. It's the first time in my life, one paper on archive every month since the beginning of the year, thanks to Ashutosh, Ali, Sanjoy, Chang-Sik, Junsei, and Namyoon and others, right? And I hope I forget nobody. So I don't want to insist too much on that. What I want to say is what we do also on this warning governments that not listening is not the right thing to do. So thanks to the Académie des Sciences, we proposed in the G7. I remind you that the countries of G7 are Canada, France, Germany, Italy, Japan, and United Kingdom, and United States. We propose one of the three topics of this year to be constellations of low orbit satellites, right? And so the aim is to indeed inform international policy makers, right, of the current available scientific knowledge and to warn them of what they might regret not to have known. And so we worked for about 1 year full time as a group of 4 persons. So I mean, each of us 1/4 of our time to prepare a statement, which was interestingly enough discussed and prepared jointly by the academies of sciences of the 7 G7 countries, signed by including the National Academy of Sciences, despite warning them that I mean the current status intensification is not sustainable, and that more should be done in order to enhance knowledge of how these things should be designed and create new regulations which make that this thing, the current ITU regulation is first come, first serve. You have the money, you are China or you or you are Amazon, you go and first come, first serve, populate these things without any understanding of the carrying orbital capacities, right? And so there are lots of quite huge dangers ahead. And we were fortunate to be with the heads of the Academy of Sciences and the 3 experts. I was one of them to deliver this report to Emmanuel Macron in May. And you will find more on this report on the site of the Academy of Sciences. Okay, I'm done in 15 minutes, a bit more.